reflection. How can we see our image in the plane mirror? We can see our image, correct? And that will be same like us only, correct? Then what is required to get the image in the plane mirror, we will see. Now whenever image we are getting, there is an object. That particular object's image only we can see in the mirror. Now here object means from where we take the light rays. That's all. Okay. So this object will be a point of intersection of incident rays. Intersection of incident rays. So from this only we take all the incident rays. That is object. We generally take a small size object, like our objects will be with a single dimension or point size. If we are taking object as point size, then that object is called as point sized object. Okay. Otherwise we just take with one single dimension like height. It will be vertically placed like this, how we stand in front of the mirror. Understood? So this also we just consider as object. Understood? Now let us see, by taking a point object, how we get the image in the plane mirror. Now I am just taking a plane mirror. In front of that I will place an object O. Okay. Now I am taking rays from the object. If I have to get image, minimum 2 rays are required. How this object is point of intersection of incident rays, image will be formed with intersection of reflected rays. Okay. Now let us see incident rays falling on the mirror, what happens. Now one ray I am taking normal incidence. You know what is normal incidence already. Then see, here you have I, here you have R and N also. Understood? Then one more I am just taking here with certain angle. Then how will be the reflected ray? Like this, correct? This is I2. Here let us take this as I1 and this is R1. This is R2. Now if you observe, R1 and R2 are moving in different directions. If you just extend also, see here, this is going in different direction and this is going in different direction. Both R1 and R2 if you observe. Is there any possibility that this one and this one meet in reality? No, they cannot meet. So that what we can do? If they are not meeting, there won't be any image formed. Okay. Now, as they don't meet in reality, what we have to do is, we have to extend them behind the mirror. Just reflected rays, extend them behind the mirror. I'm just extending. Okay. Now, see here. After extension, they are meeting here. Okay. Now, as they are meeting here, what happens here? Image will be formed. This is the image formed of this point object. This is what object O I have taken. Now this image is formed due to the extension of reflected rays. That's why this image is called virtual image. Really they don't meet. That's why we have extended behind the mirror and we are calling it as virtual image. Now image means it is the point of intersection of reflected rays. But whenever reflected rays are extended behind the mirror and it is forming image, that is called virtual image. Understood? Now there will be different characteristics of this image. Let us learn them. Okay, for learning it, we'll just take one graph paper again. Then I'm just taking a plain mirror. Same thing, take any object here at this place. Okay. In front of the mirror, fourth box I have taken. Now take the rays, whatever I have taken now, the same rays I am taking. This is R1, I1, and then one more I will take here, and then if you observe the same angle I have to draw. That's all. Okay. Now this is I2 and R2. Let me extend them behind the mirror with some different color. I am just extending. Okay. Now if you observe, check this, where you got the image. This is object, right? This is image. Now if you observe carefully, this is the first box, second box, third box and fourth box. Now this is also same, first, second, third, fourth. Understood? At the fourth box only you have image formed. Now from this mirror, if you measure this distance, and from the mirror to image if you measure, this distances will be equal. Generally from the mirror to object, the distance is called object distance, denoted with letter U. And from mirror to image, the distance is called image distance and denoted with letter V. Okay. If you observe, the distances are equal. And the sizes also you observe, they will be equal. Understood? The same size you can see in the mirror. If you stand yourself also, you can observe. Or you take any small object in your hand also, it will be same. Understood? These are the two characteristics. The distance, object distance and image distance will be equal. And the size of the object is equal to size of image. Understood? And it is virtual image and it will be erect. Erect means what? Same, straight. However you stand in front of the mirror, your image also will stand like that only. That is called erect. And the size is same size. Very, very important. And then one very, very important characteristic of this image is, the image is, what happens if you just raise your right hand, stand in front of the mirror and raise your right hand. In your image, it is seen like the image is lifting left hand. Am I correct? So this property or this characteristic of this virtual image is called as lateral inversion. What is this called? Lateral inversion. That means sides will have difference. They will be inverted. Left appears as right and right appears as left. That is the phenomenon of lateral inversion. Understood? These are the characteristics of image.